Hello and welcome, programmers! Today we're going to be talking about a topic that confuses a lot of people, and I wanted to get a video out there that kind of helps clarify it and hopefully makes it a little bit easier for you to understand what we're talking about when we reference concurrency versus parallelism. So, why? Why do we care? Well, concurrency and parallelism, they're very related to each other, but they are not the same thing. And I see a lot of cases where people mix the two terms up and they use them interchangeably when they really shouldn't, okay? Both of these methods increase the efficiency of computational cycles. So they make things run a lot more smoothly, and they allow you to do multiple things at the same time. However, they are, as I said, used interchangeably. This is incorrect, and so I'm hoping that this will help clarify when should you use one phrase versus the other so that you don't confuse other people by using the wrong phrase, okay? It's confusing to a lot of developers. I get that. I was confused by it for the longest time, and when it finally clicked, I went, oh, I get it now. I understand. So it is super important that you understand what you're talking about when we reference either concurrency or parallelism. Okay? So let's start with concurrency. What is concurrency? Concurrency simply means that an application is making progress on multiple tasks. Okay? In a non-concurrent system, you might be able to run one thing at a time. So I'll run all of task 1, and then I'll run all of task 2. But on a concurrent system, the CPU actually pauses execution on task 1 to start task 2, and then pauses execution on task 2 to continue task 1, and then so on and so forth. It continues to pause on both of those tasks, switching out which one it is working on at any given time until one of them is complete or both of them are complete. That's what we're talking about when we're talking about concurrency, sharing a single CPU resource efficiently between more than one task being done at the same time, okay? This way, you can get multiple tasks done. So if you have a very short task and a very long task, and let's say you have hundreds of small, tiny tasks, you can now take turns on each of those, get one of the tiny tasks done in between steps of the largest task that you have. And you can now fit in more work onto your CPU, even though you have a task that would, under a traditional system, hog the processor until it is done working. Okay? So parallelism, a little bit different. The application is executing multiple tasks simultaneously. Okay? This is best seen in multiple processor systems. So let's say you have 2 processors and 2 tasks. Each processor takes one task and works on it until completion. Okay, you're not taking turns, you're not swapping out memory, you're not swapping out context. You're picking one task on one CPU and another task on another CPU. They both run all the way through until completion. So we can have cases, because I said that they're both related, but they're not the same thing, where you have a system that is concurrent but not parallel. We're running multiple tasks on a single CPU. This is the exact example we gave when we talked about concurrency. We have 2 tasks, we just take turns running small steps, small increments of each task on a single CPU until one or both tasks are complete. We also have a case where we can be parallel but not concurrent. Okay, now what do we mean by this? We mean it's a single task that's split into smaller steps and run across multiple CPUs. So let's say you only have one task in your entire program, and you have multiple CPUs, and you have a way to efficiently chop up which part of the task is being performed. We can commonly call these subtasks, all right? Let's say you might have a series of steps that can be completed, and some of them can be completed simultaneously. In that case, you have a system that is parallel but not concurrent. But that isn't super common. Instead, what we usually see are systems that are both parallel and concurrent, or just concurrent. What do we mean by parallel and concurrent? We have multiple tasks split across multiple CPUs. All right, it doesn't typically happen that task 1 is being run on both CPUs and task 2 is run on both CPUs, but you can have it where they both have parallel subtasks that can be run on multiple processors. And each of the processors is sharing processing time between each of the parent tasks. Okay. What typically happens in these environments, though, is that you have hundreds of tasks being run on multiple CPU cores, and each of those CPU cores is taking turns and trading off between several tasks at the same time. Now, what do I mean by CPU core? That's something that's important to understand before we call this the end of the lesson. Modern CPUs are actually split up into what are called cores, which means entire self-contained CPUs by themselves. So a single CPU that's 8 core is actually 8 CPUs running on a single chip. And that's an important concept to understand when we're dealing in the world of parallelism and concurrency. Okay, so now we can take a multi-core chip and we can efficiently split the amount of work that we have to do across all of the CPUs, and we can take turns doing all of the tasks. So hopefully that helps clarify what all of these tasks actually mean. If you have any questions, feel free to post them in the comments below. I would love to post some additional videos on this topic if there's anything that's still confusing for you. If you liked what you heard here, go ahead and hit that like button and subscribe to the channel for more content like this. Thank you all so much. I look forward to seeing you